So question 6, how do gas particles produce a pressure on the walls of the can? The gas particles are colliding with the walls of the container, and that gets us the first mark. Collisions with other gas particles, although they do happen, they don't provide any pressure of the gas, so you don't get a mark for saying that. The force on the wall of the container when the gas particle collides with it needs to be mentioned, and then because there's a force and you've got a surface area, which is the internal surface area of the can, then because of that you've got a pressure. But it's not enough just to say it collides with the walls of the container and therefore you get a pressure. You've got to mention the force and you've got to mention the surface area. For part 2, if the level of the liquid goes down, then most of you identified the fact that that means that there's more volume for the gas. So if the volume increases, then there's a couple of ways that you can say it. You can either use Boyle's law, which is P1V1 equals P2V2, and you can say, okay, if this number here increases, then the only way for this side of the equation is constant. So the only way that can increase is if this decreases. That's one way of saying it. The other thing that you could say is that pressure is proportional to the inverse of volume. So if the volume increases, then the pressure decreases, and that's just as valid. So the final mark comes from evaluating the conclusion and saying that yes, the conclusion is correct. And the final part of the question B, what happens to the average speed of the gas particles when the spray can is warmed? So this means that the temperature is increasing, which means that the velocity, the average speed is, this means that the average speed is also going to increase. And some of you remembered the relationship that the Kelvin temperature of the gas is directly proportional to the average kinetic energy of the particles in the gas.